My name's Nicky Ringland. I'm a product manager in Google Cloud, and I'm joining you from the Eora lands of Sydney, Australia. Today, I'm going to give you an overview of Open Source Insights, a new initiative helping developers explore and understand their dependencies. Creating software has become more and more complex. Developing using open source libraries lets developers build things faster, and organizations can be more nimble. We all can be more productive. Open source essentially stops us from having to reinvent the wheel. But while adding a dependency might mean less work than writing it yourself, it's not no work. Open source software is much more dynamic than the old way of working, and it's hard to keep up with. And that brings with it a bunch of ongoing maintenance burden. At its core, Open Source Insights is an accurate dependency graph model for open source ecosystems. We aggregate information on dependencies, security vulnerabilities, licensing, and other package health metrics, enabling tools that support building safer and more robust software and products. Because just like old Captain Napkins here, dependency problems can get pretty hairy. We've got an API and a website and some exciting planned integrations, and I'll give you a sneak peek demo shortly. But first, let's take a step back. What do I mean when talking about dependency problems? Let's say you're writing package A. And to do so, you depend on several other packages that provide some functionality. And they in turn might also depend on packages, and so on. But if there's a problem deep in your dependency tree, say a vulnerability or a package with an incompatible license, that might have consequences for your project. The problem isn't isolated to package K, it could affect D, it could affect any leaf within this tree leading between it and me. And worst of all, it could affect me because of a problem in a leaf package I've never even heard of. And if the problem with K is a license incompatibility, your whole tree is infected by this license. So understanding your dependencies is critical. Understanding what's in them and how they interact with each other is important. And identifying anything surprising that might bring is a key part. But understanding these dependencies isn't always easy. In some languages especially, dependency bloat is a common or even unavoidable challenge. Having good dependency hygiene can be really hard. Now, each ecosystem is a bit different, but looking at NPM, a packaging system with over 1.6 million packages, on average, each package has 12 direct dependencies and nearly 300 indirect dependencies. Making sure you understand what's in that graph is a really big task. And adding to the challenge of the sheer size of those graphs is the fact that those graphs are constantly changing. Now, a quarter of all published packages on NPM have a change in their dependencies every day. So for an average 300 transitive dependencies, you know some of them are probably changing daily. That makes for a lot of upkeep. But why does it matter? Well, build times, download or checkout times, maintenance, testing, deployment, updating, security, licensing, compliance, these are all things that might be affected by the scale of your dependency graph. You need good information, supported by good tooling, in order to understand and be able to make good choices about your dependencies. When a new version of a package is released, it might have changed its dependencies. And if you depend on it, even 17 layers deep into your graph, your dependencies have changed. Now, different systems have different opinions on stability versus freshness. And in practical terms, this might mean pinning, where updated dependency versions don't automatically cause a change in your project. But maybe you want those new changes. Perhaps it was a patch for something bad. Even if you pin your graph so nothing ever changes, a new vulnerability might come to light tomorrow that affects your whole tree. vigilance is required. And we might like to think of our graphs as looking like this, nice orderly trees that are structured and clear. In reality, dependency graphs are complex directional graphs. They're intricate, and they can grow increasingly, outstandingly, terrifyingly large. Here we see NPM, and this delightful mess is a rendering of Kubernetes dependencies. So looking at the size of these dependency graphs, it's clearly a very complex task to keep a handle on it. It's simply beyond human comprehension. And this is really important that we do, because we know that there's stuff in the graph that might be problematic. In 2019, a study by researchers at the Technical University of Darmstadt found that 40% of all published NPM packages depend on code with known vulnerabilities. And these are scary numbers, but not unsurprising. After all, big packaging systems have big challenges. And in many respects, NPM are leading the way in tooling to help developers face these challenges. NPM Audit is a valuable tool to discover what vulnerabilities you have in your dependencies. But what do you do then? Some other systems are also developing similar tools, but they're not quite there yet. We need tooling now to help you understand what's in your dependencies and what that might mean for your project. So we're going to start our web demo at deps.dev. We can see on the right here the number of package management systems that we support: NPM, Go, Maven, and Cargo, with NuGet and PyPI on the way soon. Now let's say for this demo that we're interested in a particular web framework called Express. We'll click on it and we'll get an overview of the metadata and other information that we can use to understand this package and its dependencies. First off, we can see whether it's impacted by any security advisories, in this case not. We can get an overview of the licenses, both the license that it itself has and a summary of the licenses of all of its transitive dependencies. We also have information about the number of dependencies, both direct and indirect, and the number of dependents. In this case, we can see that it's quite a popular package to depend on. Over here on the right, we've got more metadata about the package itself: when it was published, a description, an overview of its owners, links to the package and the projects as well. And finally, at the bottom of the page, we have an overview of the event history. And this will include when new versions are released, a change to the default version, and also anything like ownership changes. Now in this case, let's say we're not interested in the most recent version of Express, but instead a slightly older version that we're still using, 4.15.5. When we click to look at that, we can see that it's impacted by a security advisory, specifically in its dependencies. We'll click on more details to find out more. Now on this page, we can see an overview of how this vulnerability affects us. We find out that the vulnerability itself is in the MIME package. We see which versions of that package are affected and unaffected. On the left here, we also have some metadata about the vulnerability itself, with links to more information, a short description, and information about the severity if available. Now this is very interesting, but we want to know how this affects us and our use of the version of Express. So let's take a look at our dependencies for Express. Here we have a list view, and we can see that MIME 1.3.4 is the issue. But actually, in order to understand our dependencies, this graph view is a much more useful tool. So in this case, let's filter our dependencies to just the paths that lead to the problematic MIME version. We can see that there are multiple ways that we depend on MIME, and so fixing this is probably going to be a quite challenging issue. It wouldn't simply involve updating one version, but multiple versions of different dependencies. Instead, what we might want to do is change the version of Express. And in fact, up here, we can click on the Compare tab to compare different versions of a package with one another. So in this case, we've defaulted to the version that we're using and the most recent version, although you can compare any version you'd like. We can see a comparison in a diff style view as to when the versions were published, their licenses, and in this case, what we're interested in is the security advisory. We can see that the security advisory in the dependency, here, MIME 1.3.4, is no longer affecting the most recent version of Express. That's great news. But we also want to look at what else has changed in the dependencies. And we can see that there's actually a not small difference between the two versions. So this might warrant additional security review just based on a change in dependencies. So that's a quick overview of some of the ways that you can use this website to understand your dependencies of open source software a bit more. And since our whole infrastructure is built on Google Cloud using open source software, we found it to be a really valuable tool in understanding our dependencies and the impact that they have. To be able to make good choices about your dependencies, you need access to the right information and the right tooling. Now, I want to call out a few key information components here. Vulnerability information is a critical component. Developers want to know if they're using a package that is affected by a vulnerability. That is, the specific version of that package is affected. But some older vulnerability formats, like CVEs, typically only include whether or not a package is impacted, not which specific versions. And that might mean more noise than signal. We're happy to see and use the shared vulnerability format for open source packages outlined in the spec here, tinyurl.com/vuln-json. It's machine readable and allows for easy automated matching of package names and specific versions. Ultimately, having really precise security information is critical to enabling developers to understand what needs to be fixed to build safe software. But vulnerabilities aren't the only thing you might want to consider when deciding whether or not to depend on a particular package. The Ossf Scorecards is an initiative of the Open Source Security Foundation, a cross-industry collaboration to improve security of open source software. Now, the scorecard defines a set of metrics and provides automated security scores for them. The goal is to automate security posture analysis of OSS and proactively help improve the posture of critical open source software. Metrics include things like whether or not a package follows code review or signs release artifacts, or whether they pin their dependencies. This information can be used by developers or organizations to make a better judgment on whether a package should be trusted and depended on. We include these scorecards for packages that have them as a good way of highlighting information so that developers can make good decisions about their dependencies at a glance. So today I've shown you a quick overview of what we're working on with Open Source Insights. And there's lots more in the works too, including supporting more package management systems like PyPI support. We're really excited about how this data can be useful for developers and the open source ecosystem. Now, maybe you're all too familiar with dependency problems, or just now have become curious about what your dependency graph actually looks like. With this new view of your dependencies, who knows what you'll discover. Check out our preview release at deps.dev and get in contact. We'd love to hear from you.